All right, welcome to today's lesson on angles at a point. I just had to remember there. Angles at a point. Now what this means is there'll be a setup that looks something like this. We might have two lines meeting or more lines meeting, and we have a whole lot of angles that we can look at. All right, now there are a few words we use to describe angles like this, so we're going to learn what they are first and then we'll put them into practice. So the first word we're going to look at is complementary. Now this is not the kind of compliments you get when your mum says your hair looks nice. This is spelt with an E and it means angles which add to 90 degrees. Okay, so if there's two angles that add to 90 degrees, they are called complementary. So if this was 90 degrees here, we would say that that angle and that angle are complementary. We can call this one A and B, so we'd say A, I write the word and instead of plus, A and B are complementary. Right, spelt with an E. Remember that. Ooh, I'm not going to fit it. There we go. All right. The next one is called supplementary. And this is angles which add to 180 degrees, or a straight line, which add to 180. All right, so if I had two angles together, so I might have one like there, you can see that and that together make a nice straight line, which is 180 degrees, and they're called supplementary. Okay? Now, vertically opposite is used to describe two angles which are on opposite sides of an intersection point. All right, so you might have two lines meeting here. Okay, now this angle and this angle are called vertically opposite, but also this angle and this angle are called vertically opposite. All right, now what else we know about them is that because they are vertically opposite and the two black lines are the same, now it's purple, in both cases, A is the same as B and C is the same as D. So vertically opposite angles are equal. All right, so I'm going to write it down. Angles on opposite sides of an intersection point, of intersection. All right, so I'm using words we looked at last week. Intersection. Okay, so vertically opposite. The next one, or next five, we probably will be familiar with, so I'll quickly go through them. So we have acute. These are angles smaller than 90. All right, so in here is an acute angle. That would be 90. So it's smaller, and I'll use the, it's the wrong one. We say smaller than 90 degrees. All right, obtuse then is the opposite, and it is bigger than 90 degrees, and it would look like this. That would be 90, and then the angle there is bigger than 90. Reflex is where it goes past 180 degrees. Oops, I don't need that vertical line. So reflex, I'll restart that whole thing. Reflex looks like this, where the angle is past 180 degrees, which would be there. All right. Revolution is an entire circle. This is why we call circles or circuits revolutions. So that would be a revolution, and a right angle, which we should all know by now, is just 90 degrees. That is 90 degrees. When we have a right angle, it's the only angle where we don't have to write the number. We can just put this little square here, and that everyone knows that means 90 degrees. All right, so those are today or this week's vocabulary words. I'm going to show you some problems we can do with them, and then we'll get on with it. All right, so in this one here, we can look at a few different things, and we can use our vocabulary words to calculate missing angles based off what we know of the properties. So we can see that there is a straight line here. Okay, it has a 90-degree angle there, which is the square one. So we could write in here that this is 90 degrees. We could also see that this straight line, a straight line needs to have 180, which means that A, B, and 90 together make 180. Because I already have 90, that means that A and B must be the other 90. So I can use some understanding there. I could also see that I have a straight line here and a straight line here, which means I have some vertically opposite angles to deal with. So A is opposite C, which means that A equals C. I don't have an angle opposite D because this third line is coming in here and wrecking the angle, but that's all right. We can move past that. Now, some of the questions you might come across will look like this, and this is one of the ones I've set, so you don't have to do this one again. We know one of the angles. We're trying to find A and B, and we can use some of the things. So we know that 27 and A together are a right angle. So I know that 90 equals 27 plus A. If I already have 27 to make up to 90, I only need to subtract 27 from 90 to find out what A is. So this will be 63. So 63 degrees is A. All right, and we can put the little degree sign there. Now to find B, we're going to use another property. We're going to use revolution or reflex angles. We know that the blue line, the blue arms together make 90. I know that in a full circle there are 360. I already have 90 here, so B is the leftovers. So 360 take away 90 is 270, and that is what B equals. All right, so we're using each of these properties at a point to work or calculate what the missing angles are. And the missing angles are given by letters. I know that's not the nice way of naming things in geometry, but that's what we're going to do in this case here. All right, so we're using these properties to calculate missing angles.